In this lesson, we're going to look at how we're going to determine if different inks were actually used on a document. We're going to use thin layer chromatography, which involves the use of a thin layer chromatography plate, which looks like this. It's a very small square, has a chalky surface on it. The first thing you're going to do in your lab is draw a pencil line. You'll follow the procedure for the height of that line. And we're going to use pencil because pencil won't bleed into the ink components. If you use the pen, it's going to also bleed, and you're going to see your pen as well as the suspect pen, and we're not going to be able to tell the difference. So we're always going to use pencil on these TLC plates or anytime we do chromatography. The next thing you're going to do, you're actually going to take the ink samples using capillary tubes, and you're going to draw the ink up off of the paper, and you're going to place an ink sample by each letter. So A would have a letter or a number from the amount on the receipt. B would be the next number. C would be the next number. So if your number was 300, A would be the 3, B and C would be the following zeros. And what we're going to do when we put that ink on the plate, we're going to then take this plate and put it into the chromatography chambers, which are glass jars that you've seen on the lab tables. And we're going to have a solvent in that jar, which is going to move up the TLC plate. And the way this works is the components of the ink are actually soluble. So the more soluble they are, the farther they're going to go on the plate. So up here, these are going to be the most soluble components of the ink, whereas the first component that you see on the bottom, that's going to be the least soluble. So on this particular example, we've got three visual components. We've got the first one here, which is like a blue-purple color, the yellow, and then we've got another purple and a blue. So these are kind of interesting because you've got them separated. You have the similar color here, but we can almost even say that there's four components. What do you notice about B and C? You should see that you've got the yellow component is the same, and you've got the purple component up here is the same, as well as this light blue. It's not totally in line with the B because it's not an exact science, and sometimes you're going to get some interference. But you're going to have this separation of the different inks. What about A compared to B and C? A looks completely different. So you should say that there's only one component here, and these two look very similar. You know, it's possible that we didn't get all four components out, but this one is so different from the other two that we can almost say that the 3 and the 300, if that was represented by the A, was probably added into the amount after the receipt was already written. And the pen that was used looked similar to, you know, the regular, you know, just looking at it with your regular eye, but when you separate the pigments out, you actually see that there's different components that make up that ink. So it looks very different. And we would say that this is a suspect document and that it was probably the 3 that was added. Usually the amounts are altered by either adding a number to the beginning or the end because they're the easiest places to add numbers in. That's why you should never leave space when you write out a check or something that has an amount for the box. Now we can take this and actually put a mathematical value to it and determine the RF value. The RF value is the retention factor. And what that is, it describes the solubility of each of the components. We're going to first look at the distance that the solvent traveled. That's going to be represented by ds. And the solvent's a clear liquid. It's going to move up the plate. And if you look closely, you can see this little jagged line up here. And you're going to mark that on your plate with a pencil after the plate runs. The solvent moves up and it separates the pigment out. That's going to be the ds. Then we can separate each of the components. DC is going to represent each of the components. So you're going to have a DC for every color that you see. We're going to focus on the blue right now. So we're going to measure from where we put the ink at letter A to the top of where the component color stopped. To calculate this, we're going to use a formula, and for our purposes, we'll say that the solvent traveled a total of 5 centimeters and the blue component traveled 1 centimeter. The equation is RF equals DC divided by DS, so the distance the component traveled divided by the distance the solvent traveled. We would set it up like this. It would be 1 centimeter divided by 5 centimeters, and then our RF value would be 0.2. There is no unit for RF because notice that centimeters are going to cancel each other out when you do division. So we're going to leave that as RF equals 2. If we were to measure the components of each of these, which we would get a measurement and we would see that those decimals are going to be very different between A, and we're not going to have the other components, and B and C. So we would say that the suspect number here is 3 and it would be a possible forgery. So you're going to take that information and apply it to your lab and look at numbers, especially at the ends and the beginnings of your amounts.